Oh, did I explain to you guys about? No, I did not, because I haven't seen you guys since Thursday. Go ahead and get this written down, and then I'll talk about definitions. So the midpoint is the point that divides the segment into two congruent segments. So when I folded this piece of paper in half, each half should be the same length, right? Okay. Now, really quickly, just on a side note, for definitions, you guys will be writing a lot of definitions down in your notes. For quizzes and any type of assessment, you will need to know your definitions, but the only way you'll really see them is by matching them. So you'll never be asked to reproduce an exact definition for a quiz or a test, but you will need to have the understanding of what a midpoint is and can I match it to the definition. Does that make sense? Yes, nods of heads. Okay, I think that's a pretty good understanding. On your midterm, there are two problems on your midterm where you do need to produce a definition to two different terms. Yeah. Well, we change them as we go along to update them to Common Core standards and all that good stuff. As that's what we do in the mornings. We talk about fun things like that on Thursdays. It's awesome. Okay, so anyways, so now let's think about how do I find the middle of something? If I had this as my line segment, and I mashed it up with my ruler, so this was at 0, and this was at 1, 2, 3, 4, 5, 6. What's the length of that segment? 6. Where would be the middle? 3. How did you get that?
Because 3's in the middle.
Explain it in better math terms. I'm just saying it is in the middle. Scott? Half of 6. Very good. Half of 6 units is 3. If we remember when we were talking about the length of something, how do we find the length of something?
Cut in half.
Nope, that's the midpoint. To find the length of this, what are we really technically doing? Measuring it. Here we can easily count units, right? But what if I shifted this? What if my coordinates started at 3, 4, 5, 6, 7, 8, 9? Did the length of that line segment change? No, it's still 6 units. But now where does that 6 come from? What's my coordinate here?
3.
What's my coordinate here? 9. What do you do with 9 and 3 to make 6?
Add it.
Other way, subtract them, right? 9 minus 3 is 6. So remember we said that distance is the absolute value of the length or the difference of your coordinates. Okay, so if I subtract my coordinates to get 6, Scott, say it again. What do you do to get to the midpoint?
Cut it in half.
Cut it in half. So you would divide it by 3. Okay? So we're taking our coordinates and cutting it in half. Now what if I put it on a diagonal in my coordinate plane? Do I have only one coordinate at this point and at this point? Do I only have an x? If you have an ordered pair, do you only have an x? No, you have an x and a y at each spot, right? So if I wanted to find the middle of this point, what am I going to have to do with my x values?
Subtract.
Cut it in half, right? And we're going to have to cut this in half. All right, so our formula for the midpoint, go ahead and get this written down. So this gave us the length. That's, I guess, what was confusing. We don't want to subtract them. So to get our midpoint of 2 ordered pairs, you're going to add your 2 x terms together and divide it by 2. Because now you have 2 x terms. And you're going to do the same thing for your y's. So this looks really confusing, but it really is not that complicated. We're going to use an uppercase M to represent our midpoint, instead of a lowercase m, which represents slope. So think about this as having 2 points, x sub 1, y sub 1, x sub 2, y sub 2. So all you're doing is just taking your x's, adding them, cutting them in half, taking your y's, adding them, cutting them in half. Remember, your midpoint on a coordinate plane is an ordered pair, so that's why we put the parentheses around it. Okay? All right, so if we look at our first example, everybody good? Oh, we got segment bisector. Yeah, sorry. I'm ahead of myself. Whenever you hear the word bisector, what do you think? I say bisector. What are you thinking? Dawson, what do you think? Keep going. What does that mean? Hey, perfect. Okay, so I can have something being a bisector. So here we have line segment AB. Here's the midpoint M. Is that point in the middle of line segment AB?
Looks like it.
We're going to say it is. So I can have a point that is a bisector of that segment. I can have a line segment be a bisector of that segment. Can I have a line bisect it? Sure, why not? Can I have a ray bisect it? Sure, why not? Can I have a plane bisect it? I'm not even going to try to draw it. Not what it would look like. But that's going to be my plane for now. So a segment bisector can be all of those things. A segment bisector can be a point, or it can be a ray, or it can be a line, or it can be a line segment, or it can be a plane. You really don't see it as a plane very often. Most likely you're going to see it as a point or a line segment. That should be a capital or lowercase I. That intersects the segment at its midpoint. Okay? So most often you'll see it as a line. So there's my midpoint M. There I've got a line bisecting it. Because it's bisecting it, it's hitting it at its midpoint. And we know that a midpoint creates two congruent segments. I'm going to put those little tick marks there to show congruency on my segments. Okay? So here's my really bad example. This diagram is definitely not drawn to scale on this first example because that is not in the middle, point J. But we're going to pretend that it is. So don't judge me on my PowerPoint diagram skills. So here we have line segment VW, which is bisecting at point T. So that means T is the midpoint. Pretend it is. I know it's not. So because it's bisecting, when I hear that, the first thing I'm going to do is put those tally marks there, or the tick marks. I'm going to do it in a different color. Okay, now let's label. XT's length is 39.9. Let's write that. If that's 39.9, what's TY going to be? 39.9. Question's asking for the length of XY, so what are we going to do? Add them together. What's the easiest way to add 39.9 plus 39.9? Multiply by 2. But how can I do this mentally without having to use a calculator? What's the number is that close to? 40. What's 40 plus 40? 80. How many points do I need to take away? 0.2. So 40 take away 0.2 would be... Oh, 40 plus 40 is 80. 79. There we go. I was with you, Carter, on that too. I was like, what? That doesn't make sense. Okay, 79.8 units centimeters. Okay, so if you hear the word bisect, we're thinking it cuts it in half. All right, next example. Point M, this looks a little bit better, is the midpoint of line segment VW. Find VM. Ideas? Dawson.
46 by 2.
Perfect. Which makes it
23.
23. So VM is equal to 23. Okay. All right, we're just going to finish this page and we'll get to distance formula on Friday. Okay, so then let's add some algebra into our world, just like we were doing earlier, but not quite. Because M is the midpoint of VW, that makes this length congruent to this length. Would I want to use segment addition? Maybe. This plus this, so I could, don't write this because this is not right. I could do 3x plus 20 equals, well, equals what?
0, right?
Well, when it can't be 0, this is 10. But do they give us VW?
Yeah. Third, 33x minus 1.
Right, but do they give us a number?
No.
No. It would be the same thing, you were
Same
correct.
thing on the other side.
Right, but then you wouldn't be able to solve it because it would be the same thing on each side. So we can't use segment addition, but these are actually even easier. If this is congruent to this, isn't the lengths equal? So can't we just equal that together? Yeah, Anna's shaking her head. She's like, I like that idea. So if we do 3x equals 20, can we solve that equation? Yeah. Add 1. 3x equals 21. Divide by 3. X is equal to 7. Now in this case, it just says solve for x. Because it would be silly if they asked us for Vm, because then we could just say Vm is equal to 20. We wouldn't have to do any work. So we stop there. Okay. All right, and the last thing we're going to do is the actual midpoint formula, and you'll see how easy that it really is. Use the midpoint formula to find points, the midpoint of R and S. Now really quickly, don't put this on your notes, I'm just going to make a visual of what's happening. Point R is at 1, -3. S is at 4, 2. If I connect them, can we take a guess on where we think the midpoint would be? Maybe somewhere around here. Maybe. Okay. So that's what's happening. We need to find that. We can do that by using the midpoint formula. If it helps you, you can label your points x sub 1, y sub 1. So this is point 1, so I'm going to label that x1, y1. This is my point 2, so I'm going to label that x sub 2, y sub 2. If you need to do that, you can. But literally all you're doing is adding your x's together. So, to find the midpoint, we're going to take 1 plus 4. So those are my x's. And I'm going to divide that sum by 2. I'm going to put a comma. Now I'm going to add my y's. -3 plus 2. And I'm going to take that sum and divide it by 2. So now I just need to simplify. What is 4 plus 1?
5.
5. What's half of 5? 2.5, right? What's -3 plus 2? What's half of -1? -half. Good. How did I do? Is my midpoint pretty close to 2.5 and -half? I think I did a pretty good job of estimating. Okay. All right. So there is your